Alright, so here we have another problem that we're going to solve, and this one is a series of solutions for each of the problem, including the geometric theorems used to solve them here. So first, we're going to identify what kind of theorem do we use out here. So first, we have the first one for the A is, yeah, you can see out here we have going to find out the chord distance theorem. Now, chords are the equidistance from the center of the circle are equals in the length. So conversely, we have, if you can see out here, we have OU is equals to OV. Now here, for the first one, then the chord we have here is AB is equals to the chord of DC then. Now, here we can see that we have a perpendicular bisector then. So we're going to apply the perpendicular bisector. You can see that the line drawn from the center of the circle that we have here is a perpendicular chord bisecting the chord then. Now, let's go try to calculate out for the first problem here. Now, looking out for the figures down here, we have O and U states that equals to OV. Yeah, OV. So let's try to make it a pointy one, OV. Now here, we have DC is equals to AB. Now, if you can look out down here, AB is also equals to 9M then. Now, to find out more about here, we can look out for the OU and DC. Now, you can look further for that. We can see that OU is perpendicular to DC then. Now, so that's going to give us with the numbers down here. Now, looking out for then, OU bisect the chord of DC. So meaning U is the midpoint of DC. So we're going to use out some of the equation down here. It means that we have for UC, we use out UC is bisected. Remember out the midpoint then, right? So they're going to have 1/2 of DC then. So DC. So that's me going to have here as the values for that one. So we have 1/2 times 9 is equals to 4.5 then. Not cm, it's m then. Okay, so that would be the value of UC then here. So that is the value for the first problem that we're able to solve here.